Well, the equations of motions we talked about in the last video are the most general form. It's also useful to look at a special case, which is the case of when we have constant acceleration. So in other words, we say that the acceleration is equal to some, so the acceleration as a function of time is just some constant acceleration, a0. Because in this case, we see that velocity is the integral of a dt. Since this is a constant, this is just equal to a0t plus v0. And then position is the integral of velocity with respect to time, which is just, so now we have, again, the acceleration's constant. The v0 term is constant, so we can pull those out of the integrals. So this becomes the integral, this is a0t dt plus integral of v0 dt, which is just a0 t squared over 2 plus v0 t plus r0. So the reason that we look at this special case is because one of the most common situations to have is if we're solving problems with particles near the surface of the Earth, where we say the acceleration is just equal to minus, well, it's equal to, in x, y, and z coordinates, 0, 0, minus g, right, where g is the acceleration to gravity. And so normally we say g is 9.8 meters per second squared, although for our calculations a lot of the times you can just use 10 meters per second squared since we're not using calculators on the exams. So now we see that the velocity is just v0 vector plus 0, 0 minus g t. And then we see the position is just r0 plus v0 t plus 0, 0 minus 1/2 g t squared. So this is kind of the most general form. We could have expanded this and written v0 as v0x, v0y, v0z minus gt, in which case our position could also be written as r0x plus v0xt, r0y plus v0yt, r0z minus, plus v0zt minus 1/2 g t squared. So you notice this really gives us three equations. We have an equation for the x component, we have an equation for the y component, and we have an equation for the z component. And because in general, this would be three different equations, because we would say that the position is going to be some final position. For example, maybe we end at the origin, and so then this gives us three different equations to solve for. If we're looking for like the time or the position or something like that.